Okay, so we're gonna start by going over the homework. Were there any that you weren't able to find? Let's start there before I just give you the answers. Tell me which one. So Angel, you said there was a couple you couldn't just find. Which ones were they? 6. During which geological period was the Earth's first coral reefs? So that is just searching the reference table. And when the Regents asks you a question about this, I guarantee you they're going to be on here somewhere. Now, one thing you can do that I addressed in this class is use these lines over here. This line right here is labeled corals. The first ones are down at the beginning, but if you go over, it does tell you, maybe it's right there, Earth's first coral reefs. So, and then make sure for that one, so question 6, it says during which geological period? So I want the period that would have been Ordovician. So again, half the trouble is just finding the words, but it is guaranteed that if the Regents asks you, they are on there somewhere. So just read carefully. So going through the homework on page 5, earliest insects would have been late Silurian. Diverse bony fishes, early Cretaceous. Earliest fishes, middle Cambrian. Earliest birds, late Jurassic. Earliest reptiles are middle Mississippian. Humans will be Pleistocene and Quaternary. And earliest trilobites are early Cambrian. Were there any that you had something slightly different? Yeah, what'd you have? For which one? Yes, and that would be, so earliest trilobites, they're down here somewhere. Wait, for H, earliest trilobites? Well, trilobites are definitely early. And they're early Cambrian, not Jurassic at all. Is that what you said was Jurassic? Yeah, that Jurassic's way up here. There's trilobites. That's the mass extinction of many land animals, including trilobites. So you had that completely wrong. It does say earliest trilobites here. So that is what I've been saying, is you have to read these carefully. If the question says earliest, you need to find where it says earliest trilobites. If it says abundant, you need to find where it says abundant. If it says diverse, you need to find diverse. If it says extinction, that's when you find extinction. So this is really important that you read carefully. Check your reference table. Here it is, right here, early Cambrian. Any other questions on any of those? All right, done with 15. Uplift of Adirondack would have been early Cretaceous. You didn't have to do C. D would have been middle Jurassic, and E would be late Triassic. Again, with these questions down at the bottom, you'll notice that I underlined what they were looking for. So again, if they ask for the geological period, they want the label, the one that's in the period column. So the Acanian orogeny. You basically just had to search the reference table for this, and luckily it's right here in bold print. It says Acanian orogeny, and that happened, they wanted the period, so you have to go across the paper. That's during the Devonian period. Then the next question says, what was the cause of the Acanian orogeny? And you come over here and you say it was caused by the collision of North America and Avalon. So it was caused by a collision of North America and Avalon, right there in black and white, no guessing required. During which geological era were the first amphibians present? That would be the Paleozoic. Again, it wants an era, so Paleozoic. Number 4, the length of the Mesozoic. Oops, I never did my math. So you know when it starts and you know when it stops. So to determine the length, you have to subtract. And 251 minus 65.5 should give you 185.5. Number 5, the answer is Paleozoic. 6, Ordovician. 7, 542. 8, again, you had to subtract, and again, I didn't do the math. So that's 54 million years. Number 9 is Devonian. 10 is near the equator. And 11 is approximately 115 million years ago. That didn't have to be right on. You could have estimated that slightly different. As long as you were between 65.5 and 146, you'd be good. Are there any that you did not get the same thing you want me to go over? There's a possibility I made a mistake too. So if you disagree with any of mine, let me know. All right, so we're gonna move on. And once again, your homework is going to be page 6. So that's the next page. And there is one adjustment, I believe. Let me double check that. But here where it says placental mammals, you're just looking for mammals. It does not say placental on there anymore. And let me just double check to make sure there wasn't any others you had to cross off. Yep. Page 6, yeah, page 6 is the next page. It doesn't have a number on it, but it is the next page. Hopefully, I'm going to try and give you some time in class to work on this. So homework, page 6. All right. So we talked in class then yesterday about pretty much all the things that could be on the reference table. The one thing I did want to clear up, I know I ran through this at the end pretty quickly, was this time distribution of fossils column. So if everybody could have their reference table out, I don't care if it's the actual blue one or if it's the colored one that we did here. And I know, again, you probably can't read mine on the board. So you'll have to have yours in front of you so you can see the words instead of just guessing what I'm pointing at. So we did start talking about the time distribution of fossils. So I want to point out, if I didn't already do this yesterday, so all these letters on these lines correspond to the letters of the fossils at the bottom. So obviously these fossils are not drawn to scale. Some of them are probably pretty similar, but like this dinosaur, letter L, Cloophysius, I'm pretty sure is not the same size as that guy next to it there at M. But these are examples of what these fossils would look like. So again, these lines represent different kinds of animals or plants that existed on Earth throughout history. Each line, so the most easiest to talk about is mammals. You guys know the gist of what a mammal is. There's also birds on there. So you can see if the line continues up to today, that means they're still around. We still have mammals, we still have birds, we still have corals. And even though you don't know what this nautilus or these ammonoids or the gastropods or bronchiopods are, we still have them. Like one of them is a clam, one's a snail, things like that. So there's still examples of them around. What I do want to talk about are these actual letters at the bottom. So we can start with letters A, B, and C. If you match letters A, B, and C up with the line over here, A, B, and C, you see that A, B, and C are on the same line. They are all, A, B, and C are all what? Go ahead from the line there that they're labeled on. What are A, B, and C? They are all different kinds of trilobites. Now, again, I think I talked about this yesterday. You can tell by looking at them that they're related. They don't look maybe necessarily like they're exactly the same, but you can see similarities with them. They all have that rounded head and the body with lines on it. Same with D, E, and F. D, E, and F are all these nautiloids, I think is how you pronounce it. So again, they're not related to the trilobites, and you can tell that by looking at them. These three pictures here. Right? Why does this not show up so great? Let's try one. That's better. So again, you can tell that A, B, and C are related to each other, and they're not related to D, E, and F, but hopefully, again, you can see some similarities with D, E, and F. They kind of look like little horns. So everything on each one of those lines are related. And the only other thing I want to talk about is the actual letter itself. So while mammals are still around, we still have mammals today. Actually, that's not the best example. So corals. Corals are still around today. We have coral reefs. You guys know that. You probably know that they are dying out, but not the point of this. They are still around. But what you need to see here is these letters T, U, and V, which are on the corals line. That particular coral, so if we come down here and look at T, U, and V, these particular corals are no longer around. These letters represent what we call an index fossil, and we're going to take notes on those in a little bit. But an index fossil is only around for a very short time period. So each one of these, so T, was only around right here where that circle is for the letter. So it's just a very, like, you'll only find T in rocks that were formed during the Ordovician period. So if you dug up rocks and they were from the Cretaceous, you would never find this letter T in those rocks. Each one of these letters only was around for that short period of time when their circle is there. There's still other corals, but not that particular coral. So that pretty much wraps up this reference table. We're going to continue to use it. We're going to come back to it. And as you guys know, it's a huge lab you're working on now, is using this reference table. So again, your homework's page 6. You will need this reference table. In the meantime, we're going to skip a little bit in our reference table or in our packet, and we are going to go to page 15. Maybe I might even go to. Okay, I'm not actually sure what page. Shoot. One second. All right, so like I said, we're going to be on to page 15 in our packet, which you can see a lovely piece of cake there. We're going to be switching over to talking about relative time. So far, everything we've done was talking about absolute time. We gave an actual real age to a rock or a fossil. Now what we're going to be talking about is relative age. So putting the age of fossils or rock layers just into order, saying this rock layer was the oldest, this one's the next oldest, and this one's the youngest. And this is called the principle of superposition. So it says, so right on page 15, I'll read it along with you. It says sedimentary rock is usually deposited in layers. In some places, the layers are tilted rather than horizontal. The principle of original horizontality states that no matter the present angle or orientation of the sedimentary layer, it is almost certain that the rock layers were deposited horizontally and were tilted after deposition. Much of stratigraphy, which is the study of strata or rock layers, is based on something called the principle of superposition. Now that's a fancy name for when there are layers, the oldest layers are on the bottom and the youngest layers are on top. And then we have here a picture. It says the layer of rocks are built up like the layers of a cake. Bakers make the bottom layer first and then the next layer on top and so forth until it's done. So again, if this was a picture of the rock layers, the oldest layers on the bottom, the youngest layers on the top. However, the principle of superposition doesn't always apply. Wind, water, and glaciers can erode entire strata away. And an unconformity, which is a buried erosional surface, and plate tectonic activity can break up or fault, uplift, or tilt older strata above nearby younger strata. A good example of this is the Lewis Thrust, an area of Glacier National Park that extends from Alberta to Montana. There, 160-kilometer long and 6-kilometer thick layer of Paleozoic sediment lays on top of several strata that are hundreds of millions of years younger. What happened? Well, originally the strata looked pretty normal, but around 75 million years ago, tectonic activity along the Pacific coast of North America caused the land of Western North America to thrust upward, creating the Rocky Mountains. In an area now known as the Lewis Thrust, these forces uplifted a big slab of Paleozoic rock and slid it 80 kilometers eastward before it finally came to rest over a layer of much younger rock. Another exemption of the principle of superposition is an extrusion. An extrusion happens when hot magma squeezes into rocks and zones of weaknesses. The magma cools as it passes its heat energy to the nearby rock. This creates a zone of contact metamorphism around the entire intrusion. Because the magma is surrounded by pre-existing rock, the intrusion is younger than the surrounding rock. An extrusion is not an exemption of the principle of superposition, but is an important concept to understand in the world of stratigraphy. An extrusion occurs at the surface. It is external. While rock below an extrusion is changed by contact metamorphism, there is no rock on the top to be changed. Sometimes geologists find a layer of igneous rocks that have not changed the rock layer immediately above it. This is evidence that the layer above it was deposited after the lava was cooled. All right, so for about the next few minutes, maybe 5 or 10, there are on page 17, 5 vocab words, or I guess they're not just words, they're phrases. And by the way, if you want to rip the reading out so you don't have to flip, that's fine with me. I don't want you yet to copy them down. I want you to go highlight or underline those words in the reading. Does anybody want me to toss in a highlighter? So again, you're going to the reading and you're looking for these phrases. So they're not really vocab words there, but they're vocab phrases. Go find in the reading and underline what principle of original horizontality is. Find the principle or law of superposition. Define faulted strata. And by the way, faulted is defined in one spot and strata is in the other, in a different spot. So put them together and you can get the whole thing. And then get intrusion and extrusion right out of the reading. So you're just going and finding those words. Guys, I'm going to actually cancel your homework. You don't have any homework tonight. So don't worry about doing page 6. We'll get to that. Again, you're just going back to the reading and finding what principle of original horizontality is. What principle of superposition, what faulted strata, intrusion and extrusion. You're just going to the reading and finding those. Look, some of you are still writing. Give you a few more minutes. Sup?
So today's our last match for the season, and it's at our home against Hal.
Nice. Should be pretty good then, right?
Yeah. We already took them at the Willows, so.
Perfect. All right, what do you guys think? What did you find for the principle of original horizontality? What did the reading say it is? And we're tilted after deposition. Perfect. That's what it says in the reading. How can we shorten that, summarize that to give us a good 10th grader definition of principle of original horizontality? What are you thinking, Jake? No, that's not. Well, let's go with the words. Principle of original horizontality. Just from that, original horizontality. Yeah, that's still pretty complicated to me. What do you guys think? Principle of original horizontality. No. Guys, which way is horizontal? No. Side to side. Horizontal is this way. These are horizontal lines. So principle of original horizontality. Original, what do you think that means? What's original? The very first, the way they were originally. What do you think horizontality means? It's a fancy word for they started out side to side. So principle of original horizontality. The definition of this is no matter what they look like now, the sedimentary layers were, I'm running out of space, were originally horizontal. So no matter what they look like now, if they're faulted, which means, well, we'll get to that. If they're sideways, if they're leaning, if they're bendy, no matter what they look like now, they were originally nice, perfect, horizontal layers. I guess, no, horizontal is like the horizon. The horizon is where the land meets the sky, and that's a perfect flat line. All right, principle of superposition from the reading. What do you got there? What is, it's a fancy name for? How can we sum that up? Okay, so I would start with when there are layers. the oldest layer is on the bottom. They get, if you want to add, they get younger as you go up, you can, but I think that's implied. I like to relate this to a laundry hamper. Do you guys know what they are? I know you're in 10th grade. That might be too fancy for you. You know what a laundry hamper is? For those of you who don't know, it's where your laundry, your dirty laundry is supposed to go, not all over your floor, not everywhere scattered through the house like my children leave it. But you're supposed to put your dirty clothes in a laundry basket so it's all in one place. So let's pretend that you do your laundry on Sunday, so you have a nice empty basket on Monday. So after your day on Monday, you put your dirty clothes in the hamper. Then on Tuesday, you put your laundry in the hamper, and where does it go? On top of Monday, which Monday is older than Tuesday. And so on and so forth. Let's say it's Friday and you're like, crud, I left my driver's license in my jeans on Monday. Where do you have to dig down in the laundry hamper to get to them? Pretty far down to the bottom, almost all the way to the bottom, probably. So the key is that the oldest laundry is on the bottom, the youngest laundry or the most recently dirtied is on the top. Same goes for the rock layers. You can't, or even the layers of this cake, where'd the cake go? The oldest layer of the cake is on the bottom. Oldest meaning the first one that got there. The youngest layer of the cake is on top, the most recent layer. All right, faulted strata. Strata was defined one place, and then fault was just defined a different place. What does strata mean? One word, pretty much. Did you find the word strata? Nobody has strata? Okay, reread it and find strata. Layers of rock. So strata, I'm going to go over here. Strata means rock layers. So what does fault mean? That was in the reading too. No, so this one I think I should reword the way I have it. In the reading, it says, and plate tectonics can break, which means to fault. A fault is simply a break. So what is then, let's put this together, faulted strata? Broken rock layers. What can break rock layers? Whole layers, not just one little rock. Earthquakes, plate tectonics. I'm just going to put that in parentheses. Only thing that can break whole layers would be plate tectonics. Go find intrusion. What is an intrusion? Yep. So it is when lava squeezes in between rock layers. And one key concept we need is what it causes. What does it say it causes? Causes contact metamorphism. All around it. And we'll wrap this up with extrusion. Extrusion sounds very similar to intrusion. But it has a different beginning. What intrusion, extrusion? What's the major difference there? Yep, so this is when lava makes it to the surface of the earth. And a key here is it only causes contact metamorphism on the rocks it touches. We are going to draw some pictures for these next time, but not today. All right, so like I said, I canceled your homework. So if you already wrote it down, please cross it off. I'm not giving you homework. You had homework already a couple days this week. We will postpone homework. So no homework tonight. That's it.